The purpose of this experiment is to observe the quantitative 1-to-1 reaction between benzoquinone and amine compounds using FTIR. The FTIR spectrometer is an instrument that identifies molecular bonding patterns by converting the vibrational energy of molecules known as the Fourier transform. It consists of a detector section and an ATR-FTIR attachment section for measuring samples and obtaining signals. By placing the sample on top of the ATR crystal and irradiating it with infrared light, the dipole moment changes, allowing the observation of resonance energy corresponding to molecular skeletal vibrations or diffraction. DHBQ is used in various household chemical products, including pharmaceuticals, dyes, and biocides. While considering how quinone substances used in biocide analysis can be detected by FTIR, we find household products often have conditions conducive to hydrogen bonding. We hypothesize that reacting benzoquinone with various substances using IR would not only reveal resulting bonds, but also show peaks corresponding to hydrogen bonding. Hydrogen bonds are very weak bonds that occur due to the electronegativity differences. However, in FTIR, bonding can significantly influence the existing covalent bond peaks, as shown in the figure on the right. Additional household chemical substances were selected to facilitate bonding among substances commonly containing amino and benzo groups. 3 amine compounds with differing pKa values were selected. By examining their FTIR peaks, we can identify the overlapping or separation of peaks based on the structural similarities and differences among these compounds. The following is a table summarizing the experimental details. Now, we will watch the experiment video. Turn on the scale, calibrate it accurately, and then measure the weight of the sample. Dissolve the sample and the comparison compounds in a chloroform solvent. Prepare the amine compounds as DHBQ. Mix DHBQ and each amine compound in a 1-to-1 molar ratio and allow the reaction to proceed at room temperature for 1 to 2 hours. This is the FTIR apparatus. Thermo Fisher Scientific is 50 FTIR, used to analyze the samples. After checking the device for any contamination or malfunctions and ensuring everything is in order, turn on the power. Click the Omnix spectroscopy software and start the program. At the top experiment selection menu, choose is 50 main sample. Click on EXPT set in the upper left corner. In the Collect tab, set the No Scans and Resolution. Set the data format to either absorbance or transmittance. In the Bench tab, verify that the signal intensity is within the normal range. If the signal is abnormal, click Align under Diagnostic to perform a realignment, and click OK. Please refer to the table to review the settings. Once the preparation for analysis is complete, first click Kernel BKG to measure the background spectrum. After the measurement is complete, set the name of the sample, then click the OK button to measure the background spectrum. Once the background measurement is complete, check for the confirmation window. Then apply the prepared sample onto the crystal. If the sample has been prepared, press the OK button to measure the spectrum of the sample. Once the measurement is complete, confirm the confirmation window. and then click Yes to view the spectrum on the screen. Save the analyzed spectrum with an appropriate name and file extension according to its purpose. To identify the main peaks in the spectrum, click Analyze and then Find Peak to accurately determine the wavelengths of the peaks. Additionally, you can use the Research button to compare the analyzed substances with the library available in the OMNIC program. After assigning the peaks of the single amine compounds and their mixtures, the comparison results are as follows. After assigning the peaks of the single amine compounds and their mixtures, the comparison results are as follows. In the 3,300 to 3,500 range of each peak, you can observe the broadening characteristic of hydrogen bonding, and an increase in the number of peaks due to the bonding. One of the precautions related to the experiment is that if the reaction is carried out at high temperatures or for extended periods, a completely new substance with stabilized energy may be formed. Additionally, if highly polar solvent is used, peaks may be obscured by the solvent, which needs to be carefully considered. Thanks for watching the video.